Hi and welcome to the fourth session of waveguide. So in the previous session we have discussed about almost all 5 topics. Now in today's session we're going to understand about the subtopics of question number 5, that is cutoff frequency, phase velocity, group velocity and dominant mode and so on. So let us start with the basic term, that is dominant mode. If you see the definition, we can observe that the technical term called as mode and cutoff wavelength, and the third term is called as maximum value. So here mode means the value of m and n. So if you substitute m as 0 and n as 0, then I can say 0 0 0 mode, or TE00 mode, or sometimes TM00 mode. So you have got the clarity, I think so. Mode means substituting the different integers value to m and n. If I substitute 1 0, then I can say 1 0 mode. It may be a TE or TM. So what we have to do is that we have to find the cutoff wavelength for different modes. So once we find the value, what we have to do is that we have to check the values. Once we check the values, the maximum value, definitely we're going to get some maximum value here for different modes, and that is called as dominant mode. Obviously it is difficult to understand right now, but I'm going to discuss all those things practically. So what we have to see here is that we have the formula in terms of AB. As you know that A is the length of your rectangular and B is your thickness. So now the four unknown values here is A, B, M and N, and the m and n refer as modes. Now we have to do this derivation part, we'll see afterwards. And what is lambda c? Cutoff wavelength. Similarly, for degenerate mode, if you observe, we have to find the cutoff frequency for different mode. Again the same story, you have to substitute 0 0 0 1 1 0, it's up to you. So now once you substitute the modes, then you're going to get some value. So once you check all the values, if any one of the value is same, let us say that 1 1 mode is whose cutoff frequency is equal to 2 1 mode, then I can say that it is called as degenerate mode. I hope you have understood. If any doubts, please ask me in your WhatsApp or call me directly. So let us start finding the derivation part first. Now let me find what is cutoff frequency. And obviously this term you are well known, this term is also well known as you have done in the derivation part. So what you have to do means you have to substitute a and b value. So once you substitute this a and b value, then you can see the derivation part, this can kept in the your right side. So now the assumption here for finding cutoff frequency is gamma is equal to 0. Gamma means propagation constant. Assuming that my propagation constant is 0, means there will be no signal at that instant. That is a pure assumption. At that instant we can say that that frequency called as cutoff frequency. Again I repeat, here assumption is that the signal is not at all propagating, means propagation constant is 0, and that frequency is called as cutoff frequency. So let me substitute the gamma as 0 and replace omega with omega c. So this is a mathematical derivation part. I hope you can understand, and try to find the formula. Yes, after derivation part you can find the formula like this, and try to understand that velocity of light can be given as root of permeability into permittivity. So now I can say here is that this is the frequency where the signal won't propagate. That is the concept. So again I can say that this is the cutoff frequency where the signal is not propagating. So the signal is not propagating at this frequency. So what we have to do means we have to increase above the cutoff frequency. So now I can say that if really you want to perform any operation on any modes, then your cutoff, your frequency selection should be greater than cutoff frequency. So I hope you have understood. At this frequency the signal won't propagate. So after this, that is higher of this frequency, that is cutoff frequency, we can say that the signal will propagate. So something, it acts as an high pass filter. For high pass filter we have to select a particular frequency. From that you have to increase the value. Below that value the answer is 0. I can say that the magnitude value is 0. So after FC there will be a signal. The same story I have discussed. Now this is about the cutoff frequency story. Now Cutoff wavelength is very simple derivation, as you know that lambda c is equal to c by fc. Just you substitute fc there and try to get this derivation part. I'm not explaining in depth as it is a mathematical concept. Try to understand that how exactly you can find cutoff frequency as I discussed. Now let us start the concept of modes. So as I already told that mn represents a mode. Now as we have discussed the derivation part of Tm, so let us understand the Tm modes. Now let us say that substitute m equal to 0 and n equal to 0. So now it is called as Tm00 mode. So now we got already 4 equations. We found Ex, we found Ey, we found Hx, we found Hy. Now let us start with Ex as a derivation part. Now if you observe here is that m equal to 0, n equal to 0. You substitute m and 0, m and n 0, obviously 0 into some product becomes 0. Yes, here it is a product, m is 0, because of this 0 remaining part becomes 0. Now I can say that for m equal to 0, n equal to 0, there will be no electric field. Means for this mode the Ex value is 0. Similarly, for the same equation you substitute 0 comma 1. Again I can say that because of this 0 part, that is 0 multiplication, again you are going to get Ex as 0. Again you substitute m equal to 1 and 0. Then you can say that n is 0, as sin 0 is 0, so remain whole part becomes 0. Now if you substitute m as 1 and n as 1, definitely it is not equal to 0. Once you substitute the value over here, then I can say that Ex is not equal to 0. Now I can say that for m equal to 1, n equal to 1, only the Tm will exist. So now I can say that the Tm mode exists from 1 1, that is m equal to 1 and n equal to 1. This is called as higher mode. Now if you, now this is for Ex. Now you can go for Hx, Hx, Hy, whatever. Now you can say here Hy. Now again what you have to do means you go for 0 0, substitute 0 0, substitute 0 1, substitute 1 0. The result is 0 itself. Now what you have to substitute now? 1 comma 1, then the result is not equal to 0 as the previous one. Now if you see overall here, I can say that for 0 0, 0 1, 1 0, it won't exist. Yes, try to understand again. I can see here is that 1 1 Ey exists, 1 1 Hy exists, 1 1 Ex exists, as well as Hx also 1 1. For 1 1 only Hx also exists. And this is about the modes. So once you cross 1 1, let us say 1 2 2 1 3 2 3 1 2 3, for all value it will exist. So now the conclusion is that from 1 1 onwards only the Tm mode exists. So how you can say, for existence of T modes you have to find Ex, Ey, Hx, Hy, then you substitute the m and n values. I hope you have understood. So this is about the modes. Now the conclusion is that Ex, Ey, Hx and Hy will exist for m1, 1 or 1, 2 and so on. I hope you have understood about modes. Now as I already discussed that we have to understand about dominant mode. So what I have done is that I have solved the various dominant mode. Let us say that m is 0, n is 0. If you substitute this value, the answer is infinity. Obviously it is doesn't exist. Now for 0 0, it won't exist. Now if you substitute 0 1, what we got the answer? Try to understand for this one. M is 0, n is 1. So now we will get this equation. What we got the answer? We got 2b, but as the concept basics, 0 won't exist, as well as 1 0 is not exist from the previous slides. So I can say that even though we got some value, this won't exist at all. Now let us substitute 1 1, which is exist. So I have taken that the length is greater than the breadth. So now what I have taken? A is 2, B is 1 as for diagram. Now once I substitute this A, B, then m equal to 1, n equal to 1, you just solve it, I got 1.788. Now if I go for 1 2, let us say some random values 1 2, then I got something like 0.9. Now I can say that here I got 1.7 for lambda c 1 1 and for lambda c12 I got 0.9. So it is less, it is more. So according to the dominant mode, you have to find the cutoff wavelength first. Once you found a cutoff wavelength, then you're going to get some value. The maximum value is called as dominant mode. Now what is the dominant mode here out of all this wavelength? Anyhow, the first three won't exist, next two exist. I got the conclusion that lambda c11 is greater than lambda c12. Obviously if you go for 2 2 2 3 3 2 4 2, it's a small homework part. You apply some values, definitely you can see that lambda c11 is always greater than the remaining mode. So now what is the dominant mode in Tm? Lambda c11 is a dominant mode, or simply I can say that Tm11 is an dominant mode. I hope you have understood. Next, now let us move down to the next derivation part. Uh, Next derivation part, that is guide wavelength. So guide wavelength is defined mathematically. The formula you can see in the screen, on the screen. Lambda g is equal to 2 pi by beta. And one more thing, that we can have the relation, the lambdas, that is guide, that is lambda g indicates guide wavelength, lambda naught indicates free space wavelength, and lambda c indicates cutoff wavelength. So you try to observe the three terms. One is guide, one is free space, another is cutoff. So you got this relationship. From here you try to find lambda g, which is very simplest part of this derivation part. So we got lambda g in terms of lambda naught and lambda c. Now let us go to the phase velocity, and the phase velocity, try to learn this definition. And the phase velocity is given by lambda g into f. I told that lambda g is nothing but guide wavelength. So now you can apply this 2 pi by 2 pi. Then this is a derivation part. Beta is nothing but 2 pi by lambda g. So phase velocity can be defined as omega by beta. I hope this is very simple derivation. And this is nothing but your group velocity, which is defined as a ratio of rate of change of omega by rate of change of beta. That is a differential part of omega by beta, that is phase constant. Next, now let us find the relation between phase velocity and group velocity. So we're going to find the relation between these two. Now you know this part, previous one, you know this one, you know this value, that h square is nothing but a square plus b square. Now what is gamma here? Gamma is nothing but your propagation constant, which is a combination of attenuation constant and phase constant. So in EMTL you have understood about what is attenuation. Attenuation is defined by alpha, and phase constant is defined by beta. So the assumption is that here, sorry for continuation of this derivation part, as the time is very less for recording part. So I'm going to continue in the next video, that is the relation between phase velocity and group velocity. I hope in this video we have learned about the dominant mode, we learned about the degenerate mode, for that we learned about the cutoff frequency, for that we have learned the cutoff wavelength, then we have understood about what do you mean by modes, how it can be related with ex, ey, hx and hy. And then what we have done here is that we have find some definition part, that is guide wavelength, which is a relation as you see in the on the screen. Then you have phase velocity, then you have group velocity. This relation part we're going to discuss in the next video. Thanks. I hope you have understood.